All right, let's just jump right in. If you've been tinkering with custom EV builds for any amount of time, you already know the controller is literally the brain of the whole operation. So today, we are doing a deep dive explainer on the Kelly controller. We're going to look at why it's a massive, absolute game changer of an upgrade over standard options, and more importantly, we'll demystify how you actually program it on your PC. I know it can seem a little intimidating at first, but honestly, by the end of this, you'll have the whole process totally nailed down.
So here's our roadmap for this explainer. First up, we'll compare the Kelly to standard controllers. Then we'll tackle the essential wiring connections. After that, configuring motor parameters, tuning the vehicle settings, and finally, we'll wrap up with the all-important identification angle.
Okay, part one, Kelly versus standard controllers, because every single DIY builder eventually hits this crossroads, right? You have to ask yourself, which controller should you actually invest your hard-earned money in? Well, you know those standard controllers you usually see? They're mostly designed for simple, off-the-shelf e-bikes. They handle maybe 25 to 100 amps, but they're incredibly bulky and really only give you basic plug-and-play settings. The Kelly controller, on the other hand, totally flips the script. This thing can handle a massive 80 to 200 amps, yet it's remarkably smaller and lighter. Now, it does require a PC connection via USB to set up, but instead of looking at that as a chore, you have to realize that this PC programming is actually its absolute greatest feature.
As one experienced builder pointed out, standard controllers pretty much lock you out, but Kelly controllers give you all these tunable parameters to make it work perfectly for your specific needs. You aren't boxed into whatever factory default some manufacturer decided on. You have total 100% control.
Moving right along to part two, essential wiring connections. And hey, don't let a messy workbench of wires make you nervous. We only need a handful of specific connections just to get this initial programming started. Here is your clean, simple checklist. Connect the 3 motor phases, plug in your Hall sensors, attach your PC via the USB adapter, hook up your battery's positive and negative terminals, and finally, and seriously, do not miss this one, connect pin number 7. That's the pink cable, and it's what actually activates the controller. If you skip it, absolutely nothing happens. You're also going to want to wire up a basic throttle right now, just so we can do a quick turn test later. But hold on, before you even think about touching that throttle, safety first, guys. You need to make absolutely sure your motor is either entirely off the vehicle or the vehicle is securely propped up on stands. And on this very first test, never, ever fully accelerate. Just a tiny, gentle twist is all you need. Pinning the throttle before the system is properly programmed can literally destroy your motor shaft or fry your brand new controller. So take it easy. All right, excellent. We are wired up, our safety checks are totally out of the way, and the motor turns safely. So, are you ready to step away from the physical workbench and dive into the digital side of things? Let's open up that software. Which brings us to Section 3, Configuring Motor Parameters. Once you open the Kelly software, hit the Read button, and let's jump straight to the Motor tab to define exactly what hardware we're working with. The very first parameter you'll see is called nominal motor current. Now, this trips a lot of people up because, surprisingly, this is not the actual running current your motor is going to use out on the road. It's a value used strictly by the software to calculate the identification angle later on. So, as a solid rule of thumb, just input 70 if you're rocking a smaller 500-watt motor, bump it to 80 for a 2,000-watt setup, and go with 90 if you're dealing with massive high-power builds. Next down the list is motor poles. For this, you're actually entering the total number of magnets inside your motor. And hey, if your supplier didn't tell you the pole count, you can literally crack open the motor casing and just count them manually. For sensor type, if you have standard Hall sensors, type in a 2. If you're using a resolver or a servo motor, type a 3. Finally, input your motor temperature sensor type. If you don't have a temp sensor at all, just hit 0 and move on. Now, if you do have a temp sensor, this part is brilliant. The controller will actively protect your investment. By default, if the motor hits 100 degrees Celsius, the controller steps in and slightly decreases power. At 110 degrees, it gets aggressive and cuts your power by a full 50%. And if things get crazy and hit 130 degrees, it completely shuts down to prevent a catastrophic meltdown. It's basically built-in dynamic insurance for your rig. Okay, let's jump over to Section 4, Tuning Vehicle Settings. We're clicking over to the Vehicle tab now, and this is where we get to define exactly how power is delivered from your hand straight to the road. First up here is throttle type, and this is super straightforward. Just input a 1 if you're using a standard potentiometer throttle, or 2 if you've got a Hall effect throttle. Right below that is the max frequency output.
Generally speaking, you're going to want to leave this maxed out at 1000 Hz for this controller. That ensures you are actually getting your maximum top speed. If you lower this number, you are artificially bottlenecking your motor's capabilities. Then we hit PWM, or pulse width modulation. Sounds like a mouthful, right? But it's just an adjustable frequency dial between 5 and 20 kHz. And what it does is manage a direct, physical trade-off between the efficiency of your motor versus the efficiency of the controller itself. This is exactly where the custom tuning really shines. Let's say you set a high PWM, like 20 kHz. Your motor is going to run super efficiently and whisper quiet, which is absolutely perfect for direct drive hub motors. But if you set a low PWM, like 5 kHz, the controller saves its own energy at the cost of the motor making a bit more noise. So if you're running a geared motor that's going to be noisy anyway, that 5 kHz setting is actually a fantastic choice.
And that brings us to Section 5, the grand finale, the identification angle. This is the magical step where we perfectly sync the physical sensors to the brain of the controller.
You need to follow this exact sequence to a T. Step 1. Change the identification angle in the software to exactly 170. Step 2. Click Right and then hit Quit. Step 3. Physically disconnect your battery and that pink starting pin, wait a solid 3 seconds, and then plug them straight back in. Step 4. Hands off entirely. The motor is going to start making slight noises and nudging on its own. Just let it do its thing and self-calibrate for exactly 3 minutes. Finally, Step 5. Disconnect the power one last time, reconnect it, open the software back up, and hit Read.
If you hit Read and that angle value now magically says 85, boom, you've done it. Calibration is 100% successful. The safety restrictions are officially off and you can finally twist that throttle to full speed without sweating about damaging anything. You've conquered the absolute hardest part of the setup.
So there you have it. You now have the knowledge to unlock your hardware's true potential. With this ultimate custom tuning power right at your fingertips on your PC, you are no longer chained to boring factory defaults. The limits are totally off. So the only question left for you is, what incredible electric vehicle are you going to build next? Thanks for hanging out with me for this explainer, and happy building.